Hi all, this is Madhumati, Assistant Professor, Department of Food Technology, SNS College of Technology. So in this video, let's see something about radio frequency heating. So we may all wonder what for this emerging, one of the emerging technologies being discussed in this video. So radio frequency heating is like an advanced and emerging technology for the applications of in food processing, and it is otherwise known as the high frequency dielectric heating, referring to heating of dielectric material with the help of electromagnetic energy at frequency range between 1 to 300 megahertz. And the radio frequency here have higher penetration power than that of the microwave, and the prime goal of this new technology is mainly done in order to preserve any food material and to ensure its safety and the quality of the particular food. And coming to the history of RF heating, this was first used in 1895 as a medical treatment method, and in food processing, it was first explored for blanching and then for cooking and the dehydrating purposes in the year 1960s, and they attempted many methods to use the RF heating to thaw the frozen foods. And in those studies, different frozen food materials were tested using lab scale and even industrial scale radio frequency systems. So in this you can find the principle of radio frequency heating. So based on what principle this novel technology is being implemented is nothing but what happens here is the reorientation of the molecules takes place, and the friction that occurs due to the continuous realignment of the molecules, what happens is that the ionic movement towards the oppositely charged electrode particles creates, and due to the fast changes in the polarity will cause the generation of the heat. So in this diagram we can observe that by giving from the electric power the RF heating system, what happens is that the rearrangement of the different position or the state of the oppositely charged ions takes place. So this is the basic principle behind the RF heating. So the mechanism behind this is nothing but first the food that is placed for the RF heating is being placed between the two capacitor plates, or we call it as the electrodes. This plays the role of a dielectric where a high frequency alternating electric field will be applied. So the electromagnetic energy that will transform directly into the product, therefore it will induce the volumetric heating due to the frictional interaction between the molecules, such that the RF heating mechanisms takes place. So in that case, what happens is that in few fields it will force the polar molecules to constantly realign themselves with the electric field. So this molecular movement will be very rapid due to the high frequency that is used in the field, and it will also cause the heat generation within the food materials by energy dissipation that is caused by molecular friction. So you can see a diagram here. This is like a general schematic diagram that which represents the RF heating processes. So whereas the food is kept in between the two electrodes, and that is connected with the capacitor and the voltage source. And in this slide you can see a commercially used implemented RF heating system where typically in industrial processes they use nearly 85 kilowatt per module. So this is the RF food, we call it as the RF food dryer in any industries. So what do you know when we compare about this RF method with that of the conventional heating? Conventional heating, we all know about the conduction and the radiation. Has a heat source on the outside. What happens there is heat is transferring to the surface of the material, and then it will conduct the heat to the middle of the material. That is the conventional, whereas that process has resulted in inefficient method of generation of heat. So keeping that in mind, RF heating is different, and it heats as the at the molecular level itself the particles gets heated, so it heats within the material and also heats the middle as well as the surface. So overall the complete material gets the generation of heat. So that is the basic difference between the RF and the conventional. Now let's see about the RF and microwave heating. So RF and microwave heating as mainly they differ in the frequency, direction of heating and the range of frequency that is mainly used in industry for the food heating, and also the how much megawatt penetration of the heat is being passed. So generally if we see between the RF heating and the microwave, microwave heating uses more higher frequency than compared with the RF heating, but in RF heating there is only single directional heating, whereas in microwave all the direction heating will be occurring, and also when the frequency is higher their range also gets higher, and the megawatt penetration depths also remains higher in microwave heating when compared to the radio frequency heating. And this is the diagram of the microwave versus the radio frequency heating. So in this diagram we can see there is a uniform voltage distribution is occurring in the RF heating when compared to the microwave, that is the heat gets directed in all directions. The main advantages of using this RF in any processing industry is mainly it has more benefits over the conventional and the drying methods. That is, it gives a faster heating and reduces the drying times, has more efficiency, energy efficiency is also higher, and mainly the deep penetration of the heat is also everywhere it gets penetrated, and moreover more uniform heating and drying takes place, and avoiding overheating on the surface of the product. So these are the few advantages. Also it has few disadvantages. If we see, the main thing is the equipment and the operating cost plays the more expensive than when the compare with the ohmic heating system. So whenever we compare it with any conventional or other heating system, RF is like a little costlier one. So coming into the factors that affect the radio frequency heating, there are mainly factors like dielectric properties mainly plays a major role in permeability and permittivity. So as I told, dielectric properties gets influenced by only due to the moisture content, how much amount of frequency is being applied during the alternative field, and the temperature and the chemical composition of the food material. The physical factors also may affect the heating system, such as the shape of the product position and the geometry. So these are the various applications where the RF heating is applied in any food industry. It is being used in blanching, thawing, processing of meat, sterilization, slicing of bread, baking and the drying processes. So as I told, how it is being implemented in the various different fields of the processing industry. So thawing means for the meat and the seafoods thawing it's used. Pasteurization and sterilization mainly for fruit juices, and for the liquid foods only we use RF heating. Baking and drying also, like for drying herbs, spices, or any preparation of French fries, pasta products, and the for drying of cowpea grains and all in that field. So these are previously where this RF has been applied for in any food industry. So this table shows clearly what process is implied for what type of food item and how much frequency. So in this we can understand that it is being implied in many fields of food processing. So application, as I told, in meat and fish product, for thawing of the fruit and vegetables, for beverage products, that is fruit juices, and for drying in agricultural product, and disinfection also sometimes for the disinfection purposes in the spices also we can go in for using the RF technique, and drying and the post baking. So thank you. This is about RF heating.